With 7 weeks to go to the Formula Student UK Finals, we're back at Cardiff Racing to see what progress they've made on the car. So it's exam time here at Cardiff University, but we're going to have a chat with Ryan to see what progress has been made since we last visited. So Ryan, what exactly have you been up to over these past few months?
Well, the progress of the car has progressed massively. We're actually on course of our final build, and we should be in the next couple of weeks fully rocking and rolling. So the engine should be running and we should be out testing very shortly. The car's engine's been installed, the exhaust system's been installed, the cooling systems have also been installed. We're just getting ready to plumb them all in. The front rolling assembly, that's all pretty much installed and should be finished by the end of this week. And we look to have the rear rolling assembly finished by the end of next week.
And we can see from the front of this car that you've got a few innovative ideas for the crash structure on the front this year.
Yes, this is actually a carbon fibre nose cone crash structure combined assembly. It's something that's been in the development for about 3 years now. It first started off with the idea of just some simple carbon tubes and seeing if they would crush nice and simply. And it's developed over the last 2 years to this lovely carbon nose cone structure. Now, one of the real benefits of this is that it is rules compliant, but also a massive weight saving to previous designs.
So before you used to run a honeycomb core inside, do you have to do it with this structure at all?
Not at all. This structure is actually very, very impressive. So if I just take it off here, inside of here, it's been laid up inside autoclave here at Cardiff University, and it's basically made in layers. So at the front of the nose cone, it's actually very, very thin, very, very delicate, and it gets thicker as it goes more and more towards the rear of the car.
That gives you your deformation from any frontal impact.
Exactly. All the energy will be absorbed at the front, and it slowly decelerates the car as it gets more and more towards the rear of the car.
And how did you actually decide how many layers you need? Did you actually crush them to find out exactly what you could get away with?
Impressively, one of our colleagues here, one of our team members, he designed and did a lot of research on how to get the best performance of these nose cones, and he took about 3 or 4 of these up to the Myra in Nuneaton, and he dynamically crash tested them. So literally drove them into the walls and basically went, what's the minimum we can get away with? What's the thinnest layer we can get away with? What meets the rules? And then he was able to decide from his testing exactly what we needed.
And from my understanding here, then the innovation that's gone to his nose cone is actually maybe above and beyond some of the F1 teams.
Yeah, it is in many ways. I mean, their sort of design is just to break it up, get rid of it as soon as possible. But we have a real specific set of design rules that we have to go to make sure that the car is safe for our drivers. All about the decelerations and the mass, the amount of energy that needs to be absorbed. It's very, very strict, and this does it all in one nutshell without the requirement for a separate impact attenuator and nose cone combination.
And I mean, compared to last year's, this is quite incredible.
Yeah, so this is actually the cone from a couple of years ago, and you can see it's actually a lot bigger. Place it on the front of the car, so it's instantly a lot bigger, and that was to house the honeycomb impact structure that actually sits inside of that.
And we've got some of that here, haven't we?
That's just it. So this is what we've typically ran in the past. You can see.
So you have that on the front.
Have this on the front, and this is what absorbed all the energy. So again, it's kind of got a similar aspect. So you've got something smaller at the front and slowly gets thicker to take more energy, so you know that the front's going to fail first.
So that has been replaced by that.
Yeah, and
that is quite incredible, isn't it? And the weight saving is just immense.
Yeah, about the same. The weight of the carbon nose cone is about the same as the nose cone itself. So right away you've saved all of that mass and some.
Wow, that's very impressive, Ryan.
Yeah, it is. It's quite an innovation. We're very proud of it.
You thoroughly deserve to be. Thank you very much.
Thank you.
What we're going to do next is we'll look at the cockpit of the car and looking at the seats and pedals. So Dowie, you've got a new seat for this year. You changed the process by how it's made. Can you talk us through what's so different about the way this seat was made compared to last year's?
Yeah, we've changed it slightly, not a huge amount, but it was all based off driver feedback from last year. So the drivers stated that they wanted a lot more lateral support within the car. So we've included a lot more support around the side of the driver's legs, the side of the driver's rib cage. We've done this through having a different construction of seat. So going from an expanding foam that we've used in previous years, we've actually got sort of a beanbag construction, if you like.
Yes.
So essentially a beanbag is fitted in the car. You put one of your widest drivers in, essentially, which is what we've done. Put him in, and this mould is essentially of him. And from that, then we can make additional moulds for some of the smaller drivers to have better support inside of this.
And obviously, one of the most important things is the driver is secure in the car, because you really can't control the car without a feeling part of the car.
Yeah, having been quite fortunate and driven these cars for 6-7 years now, driver comfort is one of the things that is so important. It's so underrated as well. If a driver is confident, comfortable, then they can actually push the car to the limits.
Well, thanks, Dowie, for showing us a seat. What we're now going to look at is we're going to get James to talk about the pedal box and some of the innovation that's gone into this. So James, we've got all the array of the cockpit equipment, and one of the most important items is obviously the pedal box. Can you tell me some of the innovation that's maybe gone into this year's compared to last year's one?
Sure. So this year we wanted to make sure that we properly record and sensorize, I guess, what happens with the pedals. So this year, as an addition, we've added, starting with a clutch pedal position, so whether it's engaged or not, it's just done by this little lever here pushing on a little micro switch below. So that's a one nice and simple one. But as well as that, the rules require that we run a brake light, so we can properly run it just like a road car. And to do that, what we ended up doing was a floating plate on the brake pedal, just attached then with another little micro switch. So any pressure on that is enough to trigger that switch and turn on the light on the rear.
So you're not reliant on the actual pedal moving at all. The fact that the driver is starting to apply a load onto that pedal is actually then triggering the
Yes,
light switch.
Exactly. So it's a very sort of simple idea. We looked at doing things like a pressure switch in the brake system itself, but of course introducing that as another point of failure, it's more complications and perhaps even more weight added to run the additional brake lines, where a simple little micro switch like that and a bit of carbon plate, and you've got a nice simple brake switch.
And what kind of load do you need to operate that? Is it quite light, or is
very,
it
very light? In
Yeah.
testing, it's pretty much just a finger's touch or something like that, which we might find we may need to fine tune a little bit if the driver's resting a foot on it, not necessarily braking, but these are all little things that we can sort out in testing.
Yeah, but if you were racing, that would be wonderful, because you just keep flashing the brake lights at people without braking, couldn't you?
Exactly.
And is there anything about the throttle? Is that electronic, or is that still wire operated?
No, we're sticking with wire operated. So
Yeah.
the rules have changed. I believe it was last year to introduce drive-by-wire if it's so you wanted. But currently the rules at the moment require so much protection around it. So things like making sure that the sensor is still responding, i.e. the car doesn't run away with itself, thinking it's on full throttle when it isn't.
Yes.
That it comes down to what's the most simplest solution, and again, a throttle by just a normal wire works brilliantly. And then of course we have the throttle position sensor on at the top of the intake just to record the current position.
And you said you got a switch on the clutch. So what kind of things do you use that information for, whether the clutch is engaged or not? What data gets triggered on by that?
So at the moment, it's basically allowed for our launch control system. It's when that starts to activate and engage from that point. But as well as that, it's all again feeding back into our large data bank of data from every point of the car that we can again map to additional points.
So I mean, a lot of times you obviously see with clutch switches affected, you can have things like flat shifters and all those kind of things. So, but you haven't got that ability on this car then?
Not quite. No, we're almost there. We are developing that, and I'm sure that's something that again we'll look at in testing. Is to push our sort of semi-auto upshift and downshift further a bit more. But yeah, it's another mechanism just to record data.
For the coming years.
Exactly.
Thank you very much, John.
No worries.
So that's it from Cardiff Racing for this episode. We'll be back in a month's time to see how testing went on.